Hey there, geometry. Had a request to do number 8. So we will take a look at that one. Hope you're doing well on this kind of dreary day. Reminder, we have the quiz then tomorrow, but today we should be working on the review 1 through 8. So this will bring us to section 11.7, where we started looking at the scale factors that happen with the surface area and the volume. So there are 12 pencils in a regular sized box. If a jumbo box is made by tripling all of the dimensions of the regular sized box, how many pencils will the jumbo box hold? Now there are some inferences we have to make. So we're talking about how much something holds. And we can hold 12 pencils currently. So you're talking about how much something holds inside of it. We are talking about the volume. So when we're looking at this one, we are looking at the volume. The second thing is we are tripling all the dimensions. Now the dimensions are the measurements of the edges, which are the linear measurements. And in a box like this, we are going to have 3 linear measurements: a length, a width, and a height. So we are tripling those measurements. Tripling is going to mean that we're going to times it by 3. So that's the other thing that we are going to end up doing. So similar to our 2 videos from yesterday, it's all about finding your scale factor. And here we're going to find a volume scale factor. So currently, our regular size box, we can think of that as just a 1. So that's going to be the linear scale factor. Then when we triple, all those linear measurements are going to become 3 times, which is a 3. So when we look at just A over B, our smaller box, or our regular box, is a 1, compared to our new box is going to be a 3. Now, whenever we're changing our scale factor to either surface area or volume, we are going to square it or cube it. And here we're going to volume, so we are going to cube our scale factor. So we're going to cube 1, we're going to cube 3. And that's going to give us then 1 to 27. So by tripling the dimensions, you're actually making the volume 27 times larger. So each linear measurement, each length is tripled, width is tripled, height is tripled. That's going to make it 27 times larger, which means it can hold 27 times the number of pencils. So my small box could hold 12. My big box can hold how many pencils? And then we'll cross multiply and divide, which is going to give us our number of pencils is going to be 324. And it's easy just to look at this and say, oh, 12 pencils, if I triple it, that's just going to be 36. But we're tripling not just the amount of volume in there, we're tripling each dimension, which actually causes the volume to go up by 27. So just a real quick visual of that. If we have the regular box, the regular box holds 12, so we'll just say that it's here's my box of 12. It's 12 wide, 12 tall, we'll say. Oops, I'm having trouble here, sorry. And well, we'd complete our box down there. But let's say our box is dimensions of 12 by 12 by 1. So I'm 12 high, 12 wide, and then 1 is my depth. This is going to have an area of 144, or sorry, a volume. Now if I triple those measurements, I'm now looking at this. And I know I'm not drawing this to scale, so forgive me. If I triple my box now, I'm looking at, I've got a 36 by 36, and then my depth now is going to be 3, which that one gives me 36 times 36 times 3, which is going to be 1,000. Just give me a second here. Forgot that one. 36 times 36 times 3 is 3,888. So the volume goes from 144 to 3,888. And if you look at how many times bigger is 3,888 compared to 144, divide those out, you're going to get 27. So there's that tripling each dimension is actually going to increase your volume by 27 times. So that's what we're seeing in this problem here. We've got our original box. Each dimension gets tripled, which means our scale factor is now 1 to 27. So the amount of pencils inside are going to increase by 27. Hope that helps. If you have any other requests, let me know.